All right, let's get right into it. In this explainer, we're going to peek behind the curtain of how the internet really works. Forget all that talk about the cloud for a second. We're getting down to the fundamental rules of the road that every single device uses to communicate. And from a cybersecurity perspective, getting this stuff isn't just helpful, it's like having a superpower.
I mean, we all use it every single day, right? But what's really going on under the hood when you send an email or load up a website? Well, it isn't magic. It's actually a beautifully structured system, a system of addresses, rules, and, believe it or not, polite conversations that are all happening at the speed of light. Okay, let's dive in.
First things first, before any two gadgets can even think about talking to each other, they have to know how to find one another. It's kind of like the postal service, right? If you don't have an address, you're not getting any mail. The internet needs that same reliable system. And that system is built on something called the IP address. Honestly, the best way to think about it is exactly like your home address. No address, no mail. On the internet, it's the same deal. No IP address, no data. It's the unique identifier for every single computer, phone, and server connected to the network. So you might be wondering, with billions of devices, how have we not run out of addresses? Well, it's thanks to a pretty clever system, public versus private IPs. Think of a big apartment building. That whole building has one main street address. That's its public IP, and it's totally unique in the whole world. But inside, every single apartment has its own number, right? Apartment 101, 102, those are like the private IPs. They only need to be unique inside that building, and whenever they need to talk to the outside world, it all goes through that one public address. And here are the most common ranges for those private internal addresses. I bet you've seen these before. If you've ever poked around in your computer's network settings, you've almost definitely seen an address starting with 192.168 or maybe a 10 dot something. These can be used over and over again in millions of homes and offices because they never ever show up directly on the main public internet. Okay, so our devices now have addresses. They can find each other. Awesome. But how do they actually talk? Just knowing where somebody lives isn't enough to have a real conversation, right? You need a shared language. In networking, we call that shared language a protocol. It's just a formal set of rules that everyone agrees on. It defines how data is supposed to be packaged, sent, and received. Without protocols, the internet would just be total chaos, a mess of devices all shouting incomprehensible noise at each other. And the absolute foundation, the bedrock protocol that makes almost everything you do online possible is called TCP/IP. The IP part, that handles the addressing we just talked about. The TCP part, well, that's all about making sure the conversation is reliable and orderly. So how does TCP make sure everything is so reliable? It doesn't just start blasting data into the void. No, it's polite. It starts every single conversation with a formal little introduction called the three-way handshake. Now, this is a really crucial point. This whole process is what makes TCP what we call a connection-oriented protocol. It confirms that both sides are ready, they're willing, and they're able to communicate before any of your actual data, your email, the web page, whatever, is ever sent. It's all about reliability. It's really as simple as making a phone call. Your computer, the client, sends out a SYN packet. Think of it as saying, "Hello, you there? I'd like to talk." The server on the other end replies with a SYN-ACK packet, which basically means, "Yep, I hear you and I'm ready." Finally, your computer sends one last ACK packet that says, "Excellent, let's begin." And only after those 3 steps is the connection actually open and ready for data to start flowing. Okay, so you've got addresses, protocols, polite handshakes. All of this is happening invisibly billions of times a second all across the globe. But what if we wanted to see it? For anyone in cybersecurity, being able to see this traffic, well, that's everything. And this is exactly why this stuff matters so much. As the cybersecurity expert Occupy the Web points out, it's kind of shocking how many professionals don't really get these fundamentals. If you do understand them, you have a massive advantage, whether you're trying to build something, defend it, or analyze it. The tool for this job is called a network sniffer or a packet analyzer. You can think of it like putting a microscope on your network cable, or maybe more like a digital wiretap. It grabs a copy of every single chunk of data, every packet that flies by, and lets you inspect it in detail. Now, what you're seeing here is a very, very simplified look at what a sniffer like TCP dump might show you. But even in this simple view, you can see the core parts of a conversation. You've got a source IP address talking to a destination IP address, and they're using a specific protocol. You can literally watch those handshakes and data transfers happen in real time. So let's tie this all together now. Why is knowing about addresses and protocols and handshakes the absolute bedrock of cybersecurity? Because it really boils down to this. You can't protect a system if you don't understand how it's supposed to talk. And you'll never find an intruder if you don't know what their shady conversation looks like compared to a normal one. Understanding the rules of the game is always step one. Think about it from both sides of the coin. If you're on defense, your job is to know what normal traffic on your network looks like, so you can immediately spot something weird, a strange connection, a messed up packet that could signal an attack. Now, if you're on offense, you're looking for clever ways to abuse those very same rules, to maybe sneak past a firewall, or hijack a conversation, or disguise malicious data to look like it's legitimate. Both sides are playing on the same field, with the same rulebook. So there you have it. We've seen how every device gets an address, how they use protocols as a common language, and how every reliable chat starts with that polite three-way handshake. This isn't just some abstract theory. It's the actual digital heartbeat of our connected world, which kind of leaves us with one final thought. Now that you know the rules, what invisible conversations are happening on your network right this second?